alarm sounds, all the rest of it. It's my pleasure to introduce Jim Bacon. Jim was my local weatherman on Anglia TV back in 30-odd years ago. He was younger then, so was I. He's done weather forecasts on radio and all the rest of it, but now has his own company that provides specialist weather data to all sorts of bodies. But he's also got very involved, as many of you will know, in linking weather and propagation in recent years. I'm particularly interested in what he's talking about today, Ionosonde data. I live very close to the Chiltern Ionosonde, but it's a total mystery to me, so I'm looking forward to this. Over to you, Jim.
Thank you. Well, good morning, everyone, and thanks for coming along. I've got a few things to say at the beginning, and one is that my initial interest in propagation stemmed more on the VHF side. And the point about that is weather does play quite a big role in propagation on VHF. The thing about the HF bit, for me, I'm not by any means an expert on ionosondes, but I do take part in contests, and we're a very active club, as some of you at the HF Awards will know, Norfolk. So we've done a lot of work with the 80-metre club championships, so that's quite an interest for us. But propagation on 80 is a really fickle thing, and especially at the start of the contest season, the 80-metre CCs used to begin in January, and now they begin in February, and of course January was quite often an incredibly difficult month to work them. So it led on to various things, like, as you do, you have a look at what information is out there, and one of the obvious sources is to tap into the professional work that's done in producing ionosondes. But of course, ionosondes are spot readings at particular times, and one of the things which we do as a matter of course in meteorology, and I'm sure in a lot of disciplines, is you get an extra insight into things if you can sort of plot out a time series of properties. Well, to do that with an ionosonde is quite a challenge, because you've got to go into the site, you've got to download all the bits, and you've got to plot it, and you can't do that while a contest is underway, so that makes it fairly difficult. So all in all, it's quite labour intensive. So what came out was a desire to put something together that would help us understand how we're doing in contests, but also to help our new licensees. The club is very active in training, and we have quite a few people come through our training courses every year. And a lot of the new licensees don't, these days, have a long history, like many of us will have done, of being SWLs for quite a period of time before you get your license. And that sort of awareness of how bands behave and the right time to be on and so on. So it was a way of trying to get behind all of that. So the early bits of this sequence is all about explaining to the beginners how it all works. And this is very much a schematic drawing, and I normally live down below 10 kilometers. So my bit of the atmosphere, if you like, is the bit of the atmosphere called the troposphere, where the weather is. So we're not really talking about weather this time, so I'm a long way from the comfort zone, but in fact very close to what determines a lot of what we do with amateur radio. So this diagram is meant to explain to folk in our courses. It's taken from our advanced license section, where we show the F layer splitting into two during the day and becoming one at night, and determining what the lowest usable frequency is when you punch up through the D layer absorption, and you can find a frequency that represents your lowest usable frequency, and you've got your sky wave to the F layer at night, so the bands appear to go long and you can suddenly work all over the place. So all of this is common meat and drink to you guys, so most of you will be very familiar with this. So differences in how the MUF behaves are really critical to what we do. And 1.5 hours, you think, for an 80-metre CC is quite a short contest. You sort of feel that perhaps it's not going to change too much, and once we're happy with how things are going, we've pretty much locked into what the conditions will be like. But actually, it's a really difficult time of the propagation day. And to find out what's going on at that point is quite tricky, because we've all been there and been aware of what the The FOF2 is the critical frequency is just before the contest starts. I'm sure a lot of you groups will be having your local nets on 2 meters or on sideband, saying, oh, I see the FOF2 so-and-so, and you'll be planning your strategy for the contest. And then as things go on through the hour and a half, it's amazing how it changes. And you get to the point where sort of 2/3 of the way through, you can't work any of the bulk of the people within the UK, and you're left with the wonderful GMs that keep the pot boiling and a few GWs and so on. This is from an East Anglian perspective. And it's quite good to know on the days when that's going to happen, or when it looks likely to happen, because then you can juggle your operating to make most use of the nearby stations that you know about. So part of this instruction sequence for the advanced licensees is how to choose your frequency between the MUF and the LUF and how it varies during the day. And we're all used to these diagrams. We all grow up with them, and we see them in the operator's handbook and so on. And it's a diagram, and it works well as a diagram, as a concept. But what you find you don't get, if you don't spend time as a listener, is you don't get that period where you relate what that looks like to what the band actually sounds like, to how it feels when you tune up and down the band, to why suddenly you're not hearing, in the case of the 80-meter CCs, well, you're not hearing those contacts close in, why it suddenly changes. And there's a whole wealth of information that you can get from plotting an Ionosonde trace through the 24 hours. So all of these are just looking at the textbook sort of classic cases. And it's a way of giving you the starting point. But without the receiver making the noise, it's very hard to really have that insight of what this all means until you actually spend those months and years learning your craft skills and deciding when you can work VK on the LF bands and all of that. It's all hidden in here. But it's actually how to extract it in real time. So the task became plotting the FOF2 at around the time when we were looking at contest and planning for the next season. And this is a sample of about a dozen days where you have this obvious, this is midnight on the left, and you go right the way through to the following midnight. You've got your rise of the critical frequency during the day. You've got your dawn dip just before the sun rises, and you've got this sort of ragged going on here. And the problem is the contests that we have all sort of start to come in this period here. Now, what you might not be able to see on this diagram is some grey lines going horizontally across the, I'm just going to look on this to see where it is. So across here, 3.5 megahertz, this is the 80-meter lower edge of the band. So there's a point in here in the evening, just when all the big guns are tuning up the linears and claiming their channel and getting underway for the contest, when everybody's feeling quite good about life and it's all looking very promising, and then the slippery slope comes in. These samples, incidentally, go from about the middle of November through to, rather randomly, through to or early December. So it was while I was developing this notion of plotting it to make things more visible. So one or two things jump off the page with this straight away. So these all represent different days. So a lot of variability between one day and another in some cases. In other cases, you have a clustering, a tendency to be there or thereabouts. So there's some value in having a background notion of what the ionosphere should do in terms of planning what you do on the bands, when to hold your club nets. But if you choose to be holding your club nets on a band where this is marginal, then you obviously have to be a bit sharper than just saying, oh, well, we're going to have a club net at 7:30 or 8 o'clock every evening regardless. And these two here, these two higher ones in the evening, represent very much different conditions for the local club net on 80 compared to the average conditions at that time of the year. The other thing is how much noise there appears to be on here. So when you look at an individual ionosonde, you tend to look at a fixed value and you take that information, you think, oh yes, the critical frequency is so-and-so. But it's when you see what's the expected norm of the variability in here, that you think there's a lot of information there that could explain this sort of randomness about if it's on the margins of the band you're trying to work on. This is 60 meters across here, 5 megs, and 7 megs is up here. So there wasn't particularly good conditions in general at that time anyway. So we resorted to, because incidentally, I'll just go back to this of course, doing it for every single reading, and ionosondes tend to take readings at 15-minute or 10-minute intervals. So you can imagine this represents quite a lot of work, and this is just looking at the critical frequency. So it was a lot of time spent doing that manually. And a friend of mine at work took pity on me, and he's a very good programmer in these things. He said, we can automate this, we can have a look at this. So luckily, the great resource out there is the Global Ionospheric Radio Observatory, GIRO, and they act as the depository for all the data from the ionosondes. And that means that wherever you're looking for data, there's a one-stop shop for going for this data. And down here, there's a link where you can get to the, this is based at the Lowell Observatory in the States. And you just choose your station list. This is the company, this is associated with the company that actually make the ionosondes. We have experts on ionosondes and running them, and John here, I'm sure, will be able to fill in some gaps on that side of it. So don't ask me anything about that, but ask John. But this is about how to get to the data. And the data is there so you can select from the list of the ionosondes around the world. There's way more stuff on that website than just single ionosondes. There's time sequences, there's a load of information. The question is how to translate it into what you're hearing on the band. So anyway, Chiltern, as it happens, appears here. The other one of interest in the UK is Fairford. They're only about 50 kilometres or so apart, so a general guide to conditions over southern England. And the only problem with this is that, okay, you've got to get hold of some number to have a think about what propagation might be like at the moment. But of course, the number where you are is very good for NVIS type stuff and running local nets. But if you're starting to extend your thoughts to further afield, then you really need to be looking at other numbers further afield. And once you start doing that, you get into very big data sets, and the data's already stored on this site. So we restricted ourselves to what we thought would be the procedure of having information from Fairford, because at the time, Chiltern was off, so Fairford was the one I developed it for, and subsequently, Fairford has gone off. So we moved over to Chiltern. So we've got A or a B solution to this. And because this is the conference weekend, now Chiltern's off as well. So the obvious sort of problem here is that ionosonde data is rare and valuable, yet it's so incredibly important to everything we do on HF. So one of the things is that we've got to be a little bit sort of shall we say, less stringent about expecting these things to be made available to the amateur community just because we've got a need constantly, and what's the band doing now? Can I work that de-expedition? I need to know now. This is scientific research stuff that comes into the public domain through places like this. As when I've been speaking to the guys over there, they're incredibly helpful, but as they say, if their server goes down, it's not part of a service level agreement that it has to be up for real time for a continuous period of the day. They do the best they can to do these things. It's not something that's budgeted to provide a feeding frenzy for amateurs every minute of the day. So the point is, when you visit websites that base themselves on this sort of ionosonde data, just be a little bit accepting of the fact that you won't get data all of the time. There'll be gaps in the data supply. If there's a gap, we can't do anything about it because our system is automated. It polls the server over in the States to release, shall we say, the demand. If every amateur individually polled the server, of course, there'd be a tremendous workload for them to do. If we poll it, the thing I'm going to show you always goes and checks after each ionosonde data has been uploaded. So if it isn't there, it isn't there. And going anywhere else probably won't get it. The other thing is like in a lot of things, We used to have an engineer who worked on our weather facsimile machines, and he always had the habit of coming in and you just, oh no. And he came into the office on a Friday to service the fax, and if it weren't for the fact that the valves in the back of it were very good for top band rigs and the PA stages, 6BW6s, they've got a CV number for a military valve type, a 40 something or other. But anyway, very good, and he'd say, oh yes, yeah, I'll just adjust this, because he wanted something nice to do on a Friday afternoon before the weekend, so he'd do all that, and you knew what was going to happen. He walks out the door with a parting shot, well, just see how it goes over the weekend. But of course, we're every day of the week, so you know at the weekend, after it's all been finally adjusted, it's going to slip out of adjustment and the thing will fall over. So the other thing to say, of course, getting around to the point, is that if these things fall over at a weekend or on a Friday, the chances are you might have a gap in the data until early the following week. And that's just the way it is. So we have just got to be accepting of the fact that this data comes to us as an outreach thing, if you like. There's no great sort of thoroughbred commitment to make sure that it's there. Obviously, everybody would like that, and we would all like it, and I'm sure the researchers would all like it. But sometimes there isn't the staffing, there isn't the resource to make it how we would ideally want it to be. But when it is there, it's easy to get. So you get your date, you get your month, you get your day, and then you have the list of the individual times of the soundings. So from the ones that I've checked, and I can't pretend that I've looked at all of them on that server, but they either seem to be 10 or 15-minute intervals between the soundings. Most of them are 15 minutes. Chiltern is 10 minutes, which is great, so we get extra information. So that's good. So here we have a single ionosonde. And the single ionosonde is great. It's got all of the information, more than you could shake a stick at. And for most of us amateurs who don't work in that world of ionospheric physics, a lot of this stuff down the left and along the bottom of the graph are things which will mean something to us if you have the time to look into it and understand the science behind it. As a general rule, if you don't go there very often and you don't keep up to date in your mind as to how it all works, you can get a lot of useful information here. So this is all about extracting some bits from the ionosonde. Here's the frequency going along the x-axis along the bottom, and the altitude going up here, and you all, I'm sure, know this, that you see a trace that comes through, and depending on the frequency, here's the trace going through, and this represents the frequency of the ordinary wave, and this other one is the extraordinary wave. And we've had some discussions earlier on in this weekend in various groups about how important the extraordinary wave is for some of these things as well. So although what I've looked at is just to keep data volumes manageable on a server which I'm pinching space from. So where we load it up, we're just looking at the FOF2, and we're looking at derivatives of that. And the derivatives of that, which are interesting, are what we do when you approach the ionosphere, not for the vertical critical angle for a local net, but you're looking at the more slope angle approach to it. Therefore, you need less ionization, and the idea is that you would be able to get a better range. So let's see what we're doing here. Some terms, the NVIS, this implies that we're going straight up and down again, or in the terms of most amateur clubs, if you're having a club net on 80, you are pretty much within 50 kilometers or so of the club station. Now, once you get beyond about 20 kilometers, 25 kilometers at night on 80 meters, when the band has gone, you're kind of feeling it's all ground wave, and you do tend to run out of ground wave fairly quickly. So there's a group, Norfolk's quite a big county, and there's a group of our net who fall outside of that. So there's a point where if the critical frequency goes below our net frequency, then we lose some of our members. So this figure is quite important. Another one which cropped up, and because of my original interest from the VHF fraternity on E's, there's a critical frequency of the E's layer. So this is an E's patch, which we want to look at. And then there's a calculation of the MUF. And that these figures, there are figures in there. I don't know, they don't appear on your... No, they're not. Well, there are figures there, and when you see the slides individually, perhaps, if you want to come and look at them, if you go on the Ionosonde, you'll see them. So there are figures in here, and the important thing is there's the FOF2, there's the FOEs, and if the figures were there, you'll be able to read them. And here, you've got various ranges for distance for the calculated MUF for the F2 layer. So as you go up, you start off at 100 kilometers, and on the standard Ionosonde print, it goes 100, 200, 400, 600, 800, 1,000 kilometers, then it steps to 1,500, and then it steps to 3,000 kilometers. So you've got the whole range of skip distances that you want to look at. So when it comes to your net, you know, say, based on Milton Keynes, if the FOF2 was 6.7 megs, and out to 100 kilometers, the F2 MUF 7.3 megs, then the chances are you need to be not going above 7.3 megs to get out this far, but some point in between here, there'll be a limit to where you could work on 7 megs on the 40 meter band within here. And as the distance increases, so the frequency that you can go up to increases, and you can get up to 8 megs for this range. And the important point is, for close-in stuff, 6.7 megs is still below the 40 meter band. So you're kind of saying you can work the more distant members of your club, but you won't necessarily be able to work the close-in people if they're outside of the ground wave. And going further up, then we come to the 1,000 kilometer ring, which takes you up to 10.5 megs. So you get the idea that as the distance increases, the frequency available to you also goes up. And throughout this point, for this single point in time, the critical frequency, of course, is the critical frequency. But it does give you options of going quite high up in frequency when you get to the larger area. Because of the map projection, it looks like this. So what did this lead to? This led to taking this labour of love, which took ages to do, to producing something which goes in and polls that gyro database to give you an idea of what's happening when we have all of this variability going on, this fluctuation here, you've got all of this stuff here, you've got sometimes when you can keep the band going during the dawn period. And it's an amazing difference from one day to the next that sometimes you contend with. And if you think about it, when you do your 80 meter CC contest evenings, or you have a regular net and you compare 1 week to what it happened the week before, the difference in that period can be staggering. 1 week you can have a successful net, another week you can't. And it's all tied up in how this goes. So can we do something better with that? Well, this is just simply an automatic plotting routine. The program will take the data from the gyro database and it will give us various options for how to process it. The top one is basically showing you the live data. So it's what you're getting from each Ionosonde reading as it comes in. So that will give you something like this. This is an archive data, which is the next column down, but it's exactly the same plot style. So what we have on here are several lines, but they're all the useful things that you might have looked at on the Ionosonde. So same axis, you've got the frequency here, you've got your bands, your amateur bands as lines across here. This purple line at the bottom is the FOE's frequency. The thick red line just above it is the FOF2, so that's the one that you're following through the day. And this is 7 megs here to give you an idea. This was one I plotted sometime early in October, I think it was. And then for each of these other increasingly orangey yellow looking lines, you're getting more distant MUFs. So there's a 100 kilometer MUF, and there's a 1,000 kilometer and 3,000 kilometer, and so on. 500 kilometer, I think, was the middle one. And if you hover your mouse over the graph, the tooltip will show you what the actual values are. So it's gone in and got that data from the Ionosonde database, and it tells you what the data is. It tells you which Ionosonde it's using, whether it's Fairford or whether it's Chiltern, and it gives you all of these values, and you can just move along and see what it is. So at any time when you're on your net and you notice the band going a bit long or conditions changing, you can call that up and have a look and say, oh, the so-and-so, so-and-so. And it's really interesting when you relate what you hear on the receiver to what you see on these curves. And it's not until you do that that you just sort of get the idea that you're actually seeing what... There are two things that have made it possible, in my view, really big transitions recently that have changed how amateur radio feels to us. One is the use of SDRs more commonly. So you actually see the band. You see when it lifts up and suddenly becomes alive. And whereas if you're tuning up and down manually on a rig, you'd be listening to a quiet channel, you might hear a couple of stations, but you've got no idea of the general activity on the band. So if you get into this, and you can then you can use an SDR to see when the band lifts up, you can sometimes very quickly relate that to where the curve of the FOF2 has got to, and when you look at the distances, you can actually see the range of the stations. If you're hearing suddenly nobody from G, but all you're hearing is a couple of F stations halfway down France and somebody DL from southern Germany, it ties in very closely to these figures. Now, I've only been looking at it for a few months, so it's not as if there's a long series of deciding how close to the truth this is. And of course, this is above southern England. So when you're working DLs and when you're working Spain and all the rest of it, the ionosonde you should be doing is looking at one halfway down in that direction. But as a general guide, it's a really good thing. So when the 80-meter contests go long and you're relying on the GM boys and the GWs and the EIs and GIs, then it will show up on here as to where it is. And then you can see sometimes very marked detail in the FOE's figure as well. So the archive thing, I should have said, this allows you to put in, there's some instructions on the opening page of that allows you to put in, you can choose whatever date you want, going back to when we started experimenting with it. So it goes back about 6 months, 9 months or so. So if you've got a contest that you did, and you think, wow, I really tanked in that one compared to the one 3 weeks before, you can have a look and compare the two and see what was going on. So that's a tremendously useful thing. The other thing about this display program that my colleague Dan Holly has written is that when you use this type of graphing package, if you click off any of the number series, the scale redraws. So with all of this stuff at the bottom here, the FOF2 and the short distance MUFs, they're all quite close together. If you disable the 3,000 kilometer one, then the graph will rescale and you can get a much clearer view of like that. So you then get a much clearer view of the next one up and so on. So you can switch off traces to make it clearer. The other thing is somewhere in the top right-hand corner of the image, which again doesn't appear to show up, there's 3 little bars. It comes just at the end of that word there. That icon is the icon for 3 sheaves of paper. And you press that, you get the option of saving a JPEG or whatever of that graph. So you can then store that and use it to email to your mates or whatever. So that's the live feed. Would be live if it were live, but there's nothing to show on it today. So the question I'll ask at the end will be about what we do. Having 2 to choose from, you think is sort of proofing it against failure of any one, but I've got a feeling we're probably going to need to add another one in there. So the question from the experts to the experts would be, which would you recommend? I'm thinking of the one in Belgium, but that's sort of general southern England sort of approach. And would work for the southern half of the UK. Sadly, there's nothing farther north that I think we could go to. But the thing is, this turns out to be just a really good idea when you've got conditions changing so dramatically from one day to the next because of solar activity. Just seeing that displayed this way is a very good insight into what the bands are doing. So this archive technique is really, really useful, and it does allow you to show some very good traces and trends, and you can see how the band varies during the day. So The other feature, which is the third button down, is called Compare, and that allows you to take just the FOF2 and compare on the same graph those two dates. So instead of using Archive to look back and say, oh, that was on that day, and then try and remember that while you go back to another date, this actually does put up the FOF2 for both dates. And the little tooltip, when you hover over the curve, does indeed give you the difference between the dates. So you can actually see that it was 2 megs poorer than last week, or whatever the date is. And it's a really good exercise when you're trying to teach the newcomers to the hobby, young or old, how bands work and how much difference there can be. Just being able to show new data coming in. You can never have too much data. It's very important data. The difference between one season and the next in terms of the hobby and how it feels is really important. It's stuff we grew up doing as SWLs, but it's stuff modern amateurs in their short courses tend not to be much aware of until they actually get on the bands. And sad truth is, talking in this side of the partition, a lot of people, when they do get the licenses, end up on the VHF side and local repeaters and FM and don't tend to spend too much time on the HF bands. So that's not a generalization, but some of them are like that, and that's where their fancy is. But it means they miss out on this great bit of knowledge, the background that keeps amateur radio working. So anyway, Compare is a really useful function as well. So then I thought, well, this is handy. Supposing we have a look at collecting and collating monthly averages. So what I've done on the averages bit, which is the fourth box down on the menu list, is we get an average of the FOF2. And that's really enlightening when you look at it compared to other months in the year. So this gives you the average. And then, because I developed this during the winter months, we had a look at where we were going to go with FOF2 and NVIS type local nets. But my main interest is Sporadic E, so we ended up having a look at what the FOEs does. So the monthly averages are useful for when you're planning nets, knowing what frequencies might be happening. The obvious thing to say, which you're probably thinking, is, wait a minute, this is going to depend on where you are on the solar cycle. So one of these graphs at the peak of a solar cycle would be very different to how the graph looks in the minimum of the solar cycle. So one of the things we'll be adding in the future is probably some solar calibration of this. So we'll have stored within the data what the smooth sunspot number is or some such thing. So that will give some sort of helpful guide there. But the other thing is I decided to put on the maximum of the FOEs. So the interesting thing is we know Sporadic E is a thing of the summer on the VHF bands, but we also know that it's going to change, and I've got no concept of how it changed during the winter or indeed what it might look like. So this is interesting because this particular one, which I'll just read on this what the date was, this was June of this year, and the FOEs, the purple jagged line on the top, is showing the highest FOEs of any day during the month. So whereas the FOF2 is the mean of the month, the FOEs, because Sporadic E is all about the best it can be, so the highest it can be. So the question is, that I would ask the experts is, in terms of how we're used to interpreting E's on the VHF bands, you tend to think of it as being a peak in the late morning and a peak early evening. But what you see in terms of the highest frequency that FOEs reaches, it's very much a solar peak driven, centered roughly on the middle of the day. So I'm not quite sure why. There'll be some who can explain that, I'm sure. But that, to me, I didn't expect to see. So I thought, that's interesting, because I would have expected to see a sort of a tendency to be higher values in that late morning period, and then another bunch of higher values in the early evening. But this almost looks like there's a big contribution from just the background solar ionization, a sort of Chapman layer thing, which is just giving you your normal E layer ionization. But why that should come out in there?
Say what the frequencies are, Jim. It's
Yes, this line here is 7 megs across there. It's oh no, that's 60 minutes. Let me just get my glasses on for this because it's not even very clear on the snapshot. Right, the lower line across here is 60 meters. So that's 5.2 megahertz. This is 3.5 at the bottom of the graph. The bottom horizontal line is 3.5. This is June. The second one is 5.2. The third one is 7 megs. And the fourth one is 10 megs. So as we get to the middle of the summer, you're getting the highest E's, FOEs, getting up to 10 megs. So when you go to the equinox, or thereabouts, the averaging for the month of September, which is what this is, you would compare it and you'd see you're getting a more marked peak during the day for the FO, F2. You are getting a more traditional view of how we imagine E's to be, because you're getting a peak in the late morning of the highest values for the FOEs and a peak in the early evening. So it's changed how the FOEs behaves from one month to another. And if we take the full set to give a snapshot of what it's like in January, you then get this which kind of has the FO F2 showing a very strong diurnal peak. It's a much shallower one, and on here you probably can't see it, but on the real-time data you've got the daylight period illuminated in yellow, but we don't show that on the average because of the spread during the course of a month. But anyway, a much stronger daytime peak, although the numerical values aren't necessarily radically different. Certainly the shape of the curve is, but then this to me is really a challenge as well that I'm quite pleased to see, because there is this thing that people say, E's is a summertime thing for VHF. You have your VHF hat on and you think, right, it's going to be May to June, May to August rather, and nothing much happens in the winter, and everybody says, no, you can get isolated E's in the winter. And we do have occasional sporadic E openings in December and January, particularly early January. So the interest to me was that having put FOEs on there is whether you'd pick any of things up in this particular time of the year. And here you can see there's a very strong spike here, every bit as good as some of the summertime spikes in that winter month. So the question is, what exactly is going on there with that? This is January. Now, in the upper atmosphere, jet stream heights, which we know are contributing, well, it's quite likely they're a major contributing factor to E's. Jet streams, of course, very strong in the winter months, very, very strong compared to the summer. So in the summer season, you'd get a jet stream that might be 60 knots at 30,000 feet. And in the winter months, you have a jet stream that could be 160 or even 200 knots. So stronger jet streams, potentially more turbulence, more gravity waves and all the rest of it, and generally speaking, you'd think there could be E's, but then everything else is not right. So you don't get much. But occasionally something happens to make the FOEs develop. So the question is correlating these dates with other factors. Now it could be there's some auroral input, it could be different solar input, it could be things to do with how the middle atmosphere is going. You get things in the winter months called sudden stratospheric warmings, where the whole flow in the stratosphere changes around, and that can produce a summer-like pattern in the stratosphere. Normally, the stratosphere, the bit above the weather, is very rigidly determined between a summer easterly or very slack flow and a really strong westerly in the winter. And the changeover, this is red sky at night stuff, but the changeover in the stratospheric flow happens at the same time as the east season happens. So in about May, you flip from the last vestiges of your westerly flow in the stratosphere, it flips to be a weak easterly, and it stays through until just about the end of the east season, at the beginning of September. And it may or may not be part of it. It could just be a coincidental thing, but it represents a change in the flow through which these gravity waves would have to propagate in order to get to the E region. So, worth a thought. But anyway, there's work to be done, and this graph is the sort of thing which, because it shows maximum, if you average it out in the winter, you don't see anything. But if you show the maximum value, you can see the interesting noise there that could be significant. So it's a way of saying, watch those things as well when you look at it during this coming winter, when we get some reports in there. So monthly averages can be a useful technique. And then there's one example here. Now, this is going to do very poorly on this projection, but basically it's what happens when the FOF2 during the evening in the winter, and this was sometime in January, the FOF2 dropped out completely, and our local net just wasn't happening. And nothing going on, and all of a sudden everybody's in at 599. And it was just the most fantastic transformation. So suddenly 80 meters just lit up, and that was where we go. So the point about that is, what normally you'd say, oh, this is odd, it's very good. And yet FOF2 had gone through the floor at about tea time, about 5 o'clock. And here we are in our 8 o'clock QSO in the evening, and all of a sudden, boom, everybody's 599. And it turned out that when I looked at the Ionosonde for that period, the FOEs was way up there, well above the FOF2. So if I can read it from here, the FOEs was just a fraction short of 5 megs, whereas the FOF2 was probably at the same time 2 megahertz. So the interesting thing is that our headset that says EASE is a VHF thing, and we don't need to think about it for LF. EASE is there all the while, and it does have an effect on the LF bands as well as the HF bands or the VHF bands. And it's using this visualization that allows you to say, that's why the band is outperforming everything today. So it's relating what the numbers say to what the band feels like and what you're hearing and what you're seeing on the screens of your SDRs. It's happened to varying degrees, more frequently than I thought I was going to say. I was really surprised when I saw that. I thought, oh, well, this has blown that system of planning your nets completely out of the water. And then I was very relieved when I found the EASE spike, because that does allow you to then bring back proper physics to say the bands are working as they should. And that's what this is all about. It's really nice to be able to get confirmation that you're on solid ground and you're working with things that are measurable and you can measure it. So that's another way of keeping check on it. And then this last bit is the bit where I plot jet streams in 6 hourly intervals through the day. And doing the Sporadic E season, I write a commentary. In yesterday's talk, I showed a slide of what the new one will look like. We're redesigning the whole website. There'll be a new version for dealing with the Sporadic E bit for next season, and it will allow us a sort of amalgam of all the factors that may influence Sporadic E to be put there as like a color-coded dartboard, giving you a probability of which direction the EASE conditions. There's some that are sort of global and affect everything, so like the KP index or the K index, the season, the solar flux, and all the generic global scale things are always going to be there. But the weather trigger bits, where the jet stream moves, does vary from day to day, if not from hour to hour, well, from hour to hour. So these jet stream patterns can be quite useful, and they've been significantly important in all of the seasons since I've started playing with these. Jet stream location is a key part of it, even to the point of explaining some of the transatlantic paths and the paths across northern Russia to JA on 6 meters. That when you get jet streams are either very zonal, so east-west, or when the jet stream is distorted, you get very meridional flow, and each part of that flow can become a point where E's are generated and give you these skipping points. And when I've looked at days when you've had openings in those directions, that does work out really well for these very, very elongated meridional patterns. Anyway, I've overrun the time slightly. Thank you very much for listening. But hopefully, Chiltern and or Fairford will both be on and available, and I may add another one in there to make it best of 3, and in which case we can use it. Just build up that awareness of what the numbers are while we're getting a feel for the band.
Thank you, Jim.